Chapter 1 Introduction to Life Cycle Thinking. There are 5 main stages a product or service goes through. In each stage, activities are needed which require inputs and create outputs, positive as well as negative ones. Inputs are raw materials, water and energy sources. Outputs are products or services, byproducts, emissions and waste. When evaluating the overall impact of a product or service, all stages along the life cycle must be looked at, from raw material extraction and processing till the end-of-life options like disposal or recycling. The approach to picture the impacts along the whole life cycle is called life cycle thinking. Life cycle thinking is a systematic approach to help you understanding and localizing the impacts on the environment, cost structure and people involved. As there are interdependencies between the stages, the initial choices affect all other stages. For example, with the selection of a material, the connection techniques or surface treatment of the product is also affected. So one early decision leads to consequences in later steps. The surface treatment might lead to a longer lifespan, but may also pose problems in later recycling or disposal steps. Life cycle thinking shows the consequences of decisions and related impacts and helps identifying hotspots and the lever for improvement. Life cycle thinking is a concept that considers all life cycle stages of a product, including their interdependencies from the very beginning to the very end. It is crucial when establishing a circular economy, as it takes positive and negative impacts of the entire life cycle into account. This should prevent burden shifting from one life cycle stage to another. The concept presents a helpful assistance to identify and reduce negative or even improve positive impacts, and considers the most relevant aspects along the value chain. Implementing life cycle thinking in early design stages is crucial, as a large share of impacts is set in planning and developing. The overall goal of life cycle thinking is the reduction of resource consumption and negative impacts along the value chain, and taking the right measures for improvement. Because of the high complexity and the extremely long lifetime, life cycle thinking is particularly important when working on buildings. Buildings are characterized by a high complexity and an extremely long lifetime. The investors usually are not the users, so the investment costs are separated from the operation and maintenance costs. There are many stakeholders involved, and their goals do not always match. Finally, the finiteness and austerity of land use poses a great challenge. The lifespan of buildings nowadays ranges from 30 to 60 years, or even 100 years and more. There are periodic decisions along the life cycle of the building which affect resource consumption significantly. But how to make the right choices? Life cycle thinking and assessment supports you in making fact-based decisions to optimize material and energy consumption in all phases. This also affects the life cycle costs. In Chapter 2 and 4, you will hear more about the benefits and limits of the different assessment methods. Let's summarize the benefits of life cycle thinking. It provides information on negative impacts of a product or service consumed. It helps to identify hotspots and gives support to take the right measures for improvement. Life cycle thinking helps to prevent burden shifting and creates awareness about the impact of our activities and products used. It gives a holistic view on the impacts and shows complexity of activities and their interdependencies. Life cycle thinking is a must when establishing a circular economy. Let's do a reflection on how planning and design decisions affect later steps in the value chain. Think of a piece of furniture. Try to state interdependencies between the choice of materials and the production process and the use phase. How does the choice of materials affect the producer or the user? For further information and complete references, please consult the full text of the module.